Hi, this is Prem. We are the students of NJIT. We are giving research paper presentation for Internet Higher Layer Protocol course, which is CS 656 855, and our group number is 5. And we are giving the presentation on OpenFlow, enabling innovation in campus networks. Introduction. This paper, OpenFlow, enabling innovation in campus networks, proposes OpenFlow, a new way for researchers to run experiment protocols in the networks they use every day. OpenFlow is built upon the concept of Ethernet switch, figuring an internal flow table and a standardized interface for adding and removing flow entries. The primary goal is to persuade networking vendors to integrate OpenFlow into their switch products, specifically targeting deployments in college campus backbones and wiring closets. OpenFlow is positioned as a pragmatic compression and enabling researchers to conduct experiments uniformly across heterogeneous switches with high line rated and port density. OpenFlow is presented as a versatile solution harmonizing the needs of researchers for experimenting and concerns of vendors regarding pro- proprietary information. The planned deployment at Stanford University serves as a practical demonstration with a broader call to action for universities to embrace OpenFlow in their network infrastructure. The need for programmable networks. Networks networks have become part of the critical infrastructures of business, homes, and schools. The vast installed base and a reason of experimenting with operational systems create a formidable barrier for new ideas in network research. Despite advancements, the reluctance to disrupt existing setups hampers the practical applications of innovation network solutions, reducing the real world impact. How OpenFlow enables separation of experimental and production traffic. OpenFlow facilitates the separation of experimental and production traffic in a network through the following mechanism. They are flow table management isolated through virtual LANs, controller based policies, dynamic control. In flow table management, OpenFlow allows the creation and management of flow entries in the switch flow table. Isolation through virtual LANs. OpenFlow supports the use of virtual LANs to isolate different types of traffics. Virtual LANs provides a logical segmentation of the networks, allowing experimental traffic to be continued within its design virtual LAN separated for production traffic. Control-based policies. OpenFlow employs a centralized control that communicates with switches to enforce network policies. Dynamic control. OpenFlow enables dynamic control over the network, allowing researchers to adjust flow entries and policies in real time. The OpenFlow switch. OpenFlow switch is an innovative Ethernet switch enabling researchers to conduct experiments with everyday network. It is built on an Ethernet switch framework featuring an internal flow table storing rules known as flow entries. OpenFlow provides a standardized interface for remote controls to add or remove flow entries, offering researchers control over how the switch processes packets in the network. Idealized OpenFlow switch. This is the OpenFlow switch architecture. Here we can see a secure channel is established between the OpenFlow switch and the controller, which is necessary for secure communication. The OpenFlow protocol, likely using SSL for encryption, is the method of communication between the switch and the controller. The flow table, which is likely a part of hardware is shown at the base of OpenFlow switch. There are multiple small devices connected to the OpenFlow switch, presumably functioning as the endpoints or nodes of the network. The controller is depicted as PC-style server, signifying its role in managing the flow of data through the network. Benefits of OpenFlow in experimental environment. Flexibility allows experimentation with new protocols, routers, or addressing no need for and also no need for hardware modification. Centralized control. OpenFlow controller centralizes management, enhances visibility and control over experimental traffic. And when it comes to dynamic experimentation, it changes applied dynamically, facilitates real-time adjustments and observations. OpenFlow components. There are three types: packet header fields, actions, and statistics. Packet header fields. These files define the characteristics of the packet, such as sources and destination address, protocol type, virtual LAN tags, etc. Actions. Each entry in the flow table is associated with specific actions that instruct that switch on how the process packets matching the defined criteria. Statistics. How here the OpenFlow table entries may also include statistical information tracking the number of packets and bytes for each flow. Types of controllers. There are three types of controllers in this: static controllers, dynamic controllers, and sophisticated controllers. Static controllers define a predetermined set of flow entries that do not change during the course of experiment. Dynamic controllers can dynamically add and remove flow entries during the course of an experiment. This in sophisticated controllers, these controllers offer advanced capabilities, including support for multiple researchers, each with different accounts and permission. From this, Kritika will take over.
Hello all, this is Ritika. I'm going to continue with the presentation. So first, this is the visual representation of a network, OpenFlow enabled commercial switches and routers. So in this visual representation, the OpenFlow enable commercial switches or routers. Each box represents a network device that supports the OpenFlow protocol. These devices can be switches or routers enhanced with the OpenFlow features. The arrows represent the flow of control. Researchers use these controllers to communicate with the OpenFlow enabled devices, sending commands to add, modify, or remove the flow entries. In detail, controllers initiate the addition of flow entries based on the requirements of experiments or network policies. Controllers define the criteria for packet matching, associated actions, and any statistical tracking needed. Flow entries are installed in the flow table of relevant OpenFlow switches through the secure channel. So yeah, next slide, please. Yeah, this is the example of network of OpenFlow enabled commercial switches and routers. The image shows a diagram of an OpenFlow enabled commercial switch. OpenFlow is a software defined networking protocol that allows a centralized controller to program and manage network devices. This gives network administrators more flexibility and control over their networks so they can utilize their networks efficiently. In the diagram, the OpenFlow controller is connected to the OpenFlow enabled switch via secure channel. The controller can send flow table entries to the switch, which tell the switch how to forward the packets. The switch's data path is responsible for forwarding the packets according to the flow table entries. The flow table is a table that contains rules for forwarding packets. The rules can be based on variety of criteria depending on their requirements, such as the packet source and destination IP address or port numbers or VLAN ID. And the flow table can also be used to implement complex network functions such as load balancing and traffic filtering. The following um, Following is a more detailed explanation of the different components in the diagram, such as server room, controller, access point, open flow, secure channel, normal data path, flow table. The server room is where the OpenFlow controller and the network devices are located. The controller is a centralized server that manages the OpenFlow enabled switches. It can it can send flow table entries to the switches and monitor their performance also. And the access point is a wireless device that allows users to connect to the network. OpenFlow protocol that is the protocol that allows the controller to communicate with the switches. And the secure channel. The secure channel is a secure connection between the controller and the switch. So yeah, the flow table. The flow table is a table that contains rules for forwarding the packets. Next slide, please. Yeah, the open floor consortium. Uh, in this formation and purpose, membership and mission, licensing and innovation, we are going to discuss about this. So the OpenFlow consortium was established to foster collaboration among researchers and network administrators in universities and colleges worldwide, so it can be utilized more efficiently by like everyone. Yeah, its primary objective is to promote the adoption and advancement of open flow technology. And whereas the membership and mission, comprising individuals from academic and government entities, the consortium is committed to maintain the open flow switch specifications. Membership is open to those not associated with Ethernet switch vendors, ensuring a collaborative and vendor neutral environment. Licensing and innovation. The consortium operates under a licensing model that encourages the widespread use of OpenFlow switch specification by facilitating open source reference implementations and engaging with network equipment vendors. The consortium aims to drive innovation and enhance the capabilities of the OpenFlow enabled switches. Next slide, please. Um, One second. Next slide, please. Yeah. So this is the diagram of example of processing packets through an external processing device, external line rate packet processing device, such as a programmable NetFPGA router. So whereas in this diagram, the image shows a diagram of a OpenFlow enabled commercial switch. OpenFlow is a software defined network, and here the potential in yeah, so as we discussed earlier, the diagram shows the following components: OpenFlow controller, OpenFlow enabled commercial switch, normal software, secure channel, normal data path, and the yeah. So this is just an example how it is used by the uh, wherever it is required. Next slide, please. Yeah, and this is deploying OpenFlow switches, market opportunity collaboration, uh, collaboration with manufacturers and vendor support. So here, market opportunity. OpenFlow enables switches for research. So basically, here OpenFlow is used for research, researchers and all, targeting colleges and universities, especially in campuses where the campus can utilize their websites securely. Focus on existing Ethernet switches, routers, and wireless access. Collaboration with manufacturers, engaging switch and router manufacturers, OpenFlow integration. No hardware changes required. So here, any of the hardware changes is not at all required. And implementation via secure channel software on existing processors. So here, without any hardware changes, they can establish a secure channel on their existing processors only. And then vendor support, positive response. Obviously, with all of these securities and so many with all of these advantages, the vendors are very much supportive, willingness to support research without exposing in internal workings. Next slide, please. So, continuation of deploying open flow switches, collaborative deployment at Stanford University. So, as I've we discussed earlier, the Stanford University has also been collaborative with OpenFlow and utilizing these techniques. Initial focus on computer science and electrical engineering departments. So the computer science and electrical engineering departments have been using OpenFlow way efficiently. Replacement of network in two buildings with OpenFlow switches. Vision, transition to an all OpenFlow network with VLAN isolation. User control and flexibility. Researchers manage their traffic, add or remove flow entries, or for enhanced control. So yeah, researchers have it this OpenFlow has made easier for researchers to manage their traffic, because they keep they will be working on so much of network traffic, and th- it won't be a problem for them for their research, because they can add or remove flow entries easily. Diverse open flow switches, anticipating community driven development, research designs, Linux, Open WRT software for access points, NetFPGA, hardware 4 ports of 1GE. Encouraging developers to test against evolving reference designs. So this encourages the researchers to work more on the upcoming designs. Next slide, please. My group mate will continue. Thank you.
Hello all. Now this is Purnima Parinita. From now I'll continue. Challenges of OpenFlow implementation in campus networks. Here are some topics: complexity of integration, scalability issues, dependency on controller, security concerns, vendor interoperability. So first one, complexity of integration describes the difficulties in integrating OpenFlow into existing network infrastructures, particularly in campus networks where the network architecture can be complex and varied. Scalability issues refers to the challenges in scaling OpenFlow, implementing to manage large and growing campus network efficiently. Dependency on control highlights the reliance on a controlled centralized control in OpenFlow networks, which can be a single point of failure at a bottleneck. Security concerns address the security vulnerabilities inherent OpenFlow networks, such as exposure to network attacks. Vendor interoperability discuss the difficulties in achieving interoperability among different vendors, OpenFlow enabled devices, which can limit flexibility and innovation. Next slide, please. Security and perform concerns. DOS attacks, man-in-the-middle attacks, data privacy, performance bottlenecks, quality of service challenges. DOS attacks points to the vulnerability of OpenFlow networks to DOS attacks, which can disrupt network services. Man in the middle attacks indicates the risk of attacks intercepting and altering communications in an OpenFlow network. Data privacy. Concerns about safeguarding sensitive data in an OpenFlow enabled network. Performance bottlenecks. Identifies potential issues in network performance, possibly due to the centralized nature of OpenFlow controls. Quality service challenges. Discuss the difficulties in maintaining high quality of services in OpenFlow networks, particularly under varying whole load conditions. Move to the next slide, please. Future directions for OpenFlow and SDN. Enhanced security mechanism, machine learning integration, intent-based networking, 5G and edge computing integration, interoperability standards, dynamic network slicing, energy efficient networking. We'll start with the first one. Enhanced security mechanism suggests improvements in security features. Move to the slide 21. Yeah. Machine learning integration. Purpose integrating machine learning to optimize network operations and decision making in OpenFlow environments. Intent-based networking describes the shift towards network that can automatically implement high-level business policies. 5G and edge computing integration. Discuss the integration of OpenFlow with emerging technologies like 5G and edge computing for more efficient and flexible networks. Interoperability standards. Advocates for the development of standards to ensure better interoperability among different OpenFlow vendors. Dynamic network slicing refers to the ability to dynamically allocate network resources for different services and application in OpenFlow network. Energy efficient networking highlights the need for more energy efficient networking solutions in OpenFlow implementation. Prem, move to the next slide. So here are some case study for old OpenFlow implementation in campus network. Firstly, we'll see the Stanford University Clean Slate program. Stanford Clean Slate program played a pivotal role in development and early implementation of OpenFlow. The university's network architecture underwent a significant transformation using SDN principles. OpenFlow allowed researchers to experiment with new protocols and network configurations without disrupting the entire campus. Move to the next slide. And here is another case study from Indiana University's hybrid OpenFlow deployment. Indiana University implemented a hybrid OpenFlow deployment in its campus. This approach allowed the integration to OpenFlow-enabled switches along traditional network equipment. The university used it to set up, conduct experiments, optimize traffic flows, and gradually transition towards a more SDN-centric infrastructure. And the next slide, please. This is the last case study for this research paper. It is Google's before WAN architecture. Google's implemented in its before wide area network, which is WAN architecture. Before utilizes SDN principles to dynamically control network paths, optimize traffic engineering, and improve overall network efficiency. The implementation showcases how OpenFlow can be applied at a large scale in complex geographically distributed environments. And last slide. So conclusion. OpenFlow fuels network innovation through a standardized experimental platform, crucial for SDN's growth. Despite the security and performance challenges, ongoing research and collaboration drive OpenFlow's evolution to meet dynamic network needs, serving as a pragmatic compromise. OpenFlow enables experiments across diverse devices without exposing internals. Successful campus deployments may spur widespread adoption, fostering an area of interconnected OpenFlow networks, which is reusable for control software, promising a collaborative and innovative network feature. So this is the completion of the research
We have done.
presentation.
And
So
thanks.
hope you guys liked
Thank you.
and review this thing. Thank you.
Thank you all.